All right, guys, good afternoon. So today's lesson, hopefully, in addition to, reading the title and thinking about one of the best Paramore songs that's out there, hopefully today's lesson is going to give you a chance to see what you can do with some of the functions that we've been talking about. We're going to take the next few lessons and specifically zoom in on linear functions. In the next lesson, in the next unit, we'll zoom in on quadratic functions, but you'll get a chance to see where they appear in the real world. The first place that you see linear functions all the time is with percents. And percents are important with insurance, they're important with taxes and tips and all those fun things. So look at example 1. If I wanted to solve this question out, it says what? Well, in math, usually if I'm trying to find something or I don't know something, I call it x. So I'm going to use x to stand for the word what. Then it says is. Well, is another way of saying equals. So what is 64%? How do I write 64% in a way that I can actually use it? Well, normally I write percents as a decimal, and I always put two numbers after the decimal. So if I have 64%, then as a decimal, that is 0.64. Okay? Then I get to the word of. Of means multiply, and usually when we write an equation, we use parentheses to stand for multiply. What am I multiplying by? 15. So how do I find x here? Well, all I have to do is type in 0.64 times 15. And your calculator tells you that that is 9.6. So 9.6 is 64% of 15. Question 2 looks like a similar question, but it's kind of written in a different order. This time 17 comes first instead of what. So 17 is, so is means equals, 123%. How do I write that as a decimal? Well, I put two numbers after the decimal. So the 2 and the 3 come after the decimal, the 1 comes in front of it. Of means multiply, so I put parentheses. What number? So if I see the phrase like what or what number, that means I'm looking for something, and something that I'm looking for, I usually call x. So there's my equation. How do I solve that equation now? How do I get x by itself? I'm going to write this over here so I got a little more room. Well, x is being multiplied by 1.23. So to get x by itself and cancel out that 1.23, I divide both sides by it. So in my calculator, I'm going to type in 17 divided by 1.23, and it tells me that x is 13.82. And then you're done. So 17 is 123% of 13.82. Okay, our last question here about percents is something that you're going to deal with all the time, and your waiters and waitresses will really appreciate it if you figure out how to do it. So your meal at Ariela's cost $25.42. And it's common courtesy to tip 15%, okay, in case you didn't know that. So how much total should you actually pay for dinner to make sure that the waiter or the waitress gets an appropriate tip? Well, you know that you're going to have to pay the $25.42 because that's your bill. If you don't pay that, they're going to send the cops after you. But in addition to that, you should also tip. So how do I find a tip? Well, if I want 15% of my bill, then I'm going to take that $25.42 and multiply it by 15%. Which is 0.15 as a decimal. So this first part is my bill. The second part is my tip. I add those together to get the total. So I grab my calculator and I type in 25.42 plus 25.42 times 0.15, and I get 29.23. And then I'm done. Okay? So all of these are examples of linear functions because if you look at the equations that I wrote, none of them had any exponents. Okay? None of them had any kind of absolute value bars or square roots or anything like that. They're just plain Jane, they've got an x in them. Those are all linear functions. Or linear equations, would probably be a better way of saying that. They're linear equations. All right, our next example deals with two different forms that you can see when you're dealing with linear equations. We'll talk a lot more about what those mean when we get to the next lesson, but for now, just so you've seen both forms. Question 1. You bought Xbox controllers on Amazon for $74.99 each, including tax. So here's the thing. We're going to go ahead and say, since we're dealing with Xbox controllers, we're going to use an X to stand for that. Shipping cost you $5.95. Write a function to represent this scenario and use it to find the cost of 4 Xbox controllers. So how would you write a function for the cost? Well, it costs you $74.99 for each Xbox controller. So if you only bought one, it would cost you $74.99. So how do I write something that represents $74.99 times each one? Well, I'd say 74.99x. And what that means is I could plug any number I wanted in for x. If I bought 1, I'd multiply 74.99 by 1. If I bought 2, I'd multiply 74.99 by 2, and so on. But then in addition to that, you had to pay $5.95 for shipping. And we'll say that that's equal to C for cost. There's my equation right there, 74.99x, because x represents the number of controllers. I can plug in a 3, 4, 5, however many I bought, plus the shipping cost. The shipping cost is the same no matter what, because they're going to throw them in the same box either way, okay? And maybe they have a special deal. Here's the next part. It says use this equation now to find the cost of 4 Xbox controllers. Well, if I bought 4 of them, then that means I just plug in 4 for x. So $74.99 times 4 plus $5.95. And then I grab my calculator. I type that in. So $74.99 times 4 plus $5.95 is $305.91. So that's what's called slope-intercept form, okay? All that it means is that you have one number with x and one number by itself. Okay, we'll talk about that more next time. Question 2 says this. You bought used controllers for $34.50 each. So think about how you would write that as part of an equation. And we'll call this x here, okay, for our Xbox controllers. If they're $34.50 each, that's $34.50x. Because I might have bought more than one. I may need to multiply that $34.50 by a bigger number. But then you also, so in addition to that, had to pay for headphones. So we'll call headphones Y. And you bought the headphones for $64.95 each. And those are actually a reasonable price because I looked it up. So there's the first part of my equation here. $34.50 times the number of controllers plus $64.95 times the number of headphones, and that's going to be equal to our total cost. So there's our function right there. The next part says use this function to find the cost of 2 Xbox controllers and 3 sets of headphones. So that means x is 2 and y is 3. So what I'd be typing in my calculator is $34.50 times 2 plus $64.95 times 3. And we'll see what that gives us. Whatever I get is my total cost. So $34.50 times 2 plus $64.95 times 3 gives me $263.85. So there's my total cost. Okay. All right. So our next example says this. And our last example says write equations to represent the two tables below. Use them to find f of 15. Okay, so one last way that you often see linear functions in the real world is when you're dealing with data. So if you ever do any type of experiment, one of the things that you may want to do is to try to model it with some type of equation. Here's how I do it if I know that it's linear. The first thing I do is I look for a pattern, okay? So I say, look at this table here. What's the pattern on the x side? Well, every single time, they're going up by 2. What's the pattern on the y side? Well, every single time, they're going up by 16. So if I wanted to write this as an equation, what's the pattern? Well, your pattern is the rise is 16 and the run is 2. So what's 16 over 2? That's 8. Okay? So there's part of my equation. As I start to write it, the part that represents the pattern, and we'll talk about this more next time, is called your slope. That goes next to x. But you also need to know what your starting point is. And the way I find that is right here in the table. It's where x equals 0. That's your starting point. Well, when x was 0, y was 10. There's my equation. The 8 is my slope. The 10 is my y-intercept. So you may notice that looks like the first equation that we wrote on the previous slide. So if you're given data, that's how you write the equation. The second part of our instructions said, use them to find f of 15. What does that mean? Well, 15's in parentheses, right? That means they want me to plug it in for x. So f of 15 would look like this right here. It would say, what is 8 times 15 plus 10? Well, 8 times 15 is, let's see, 120. And 120 plus 10 is 130. And then we're done. Okay? Example 2 has the same idea to it. The first thing I do when I collect data is I've got to see if there's a pattern. So on the x side, I'm going up by 3 every time. And pay attention here, on the y side, ooh, I need a different color. On the y side, I'm actually going down this time, so I put a negative. I'm going down by 10. So what's my rise over my run? Well, it's negative 10 over 3. And the pattern part is my slope. It sits there with x in my equation. My next question is, what is my starting point? Well, my starting point would be wherever x is 0. So here's what I want you to think about. X equals 0 doesn't appear in this table, right? But think about where it would fall. You've got 3, 6, 9, 12. X equals 0 would come right before that. It would come right here. It would be your next cell. Well, what would come right before that on the y side? Well, if I'm going 70, 60, 50, 40, right before that would come 80. So plus 80 is my y-intercept. It's the second part of my equation. Okay? And again, if I want to find f of 15, that means take x and replace it with 15. And you're probably going to want to use your calculator for this one. So negative 10 over 3, okay, times 15 plus 80. That gives me 30. So just to recap, if you're given a data table, you need to find 2 things. The most important thing you need to find is what is the pattern in this data table. That's your slope, okay? That's the part that goes with x. The next thing you need to find is what is my starting point, okay? What happens when x is 0? That's your y-intercept. That's the last part of your equation. And again, we'll talk more about what those are in the next lecture. All right, guys, that's the end of our video.